VLSos here. This is a video lesson on function families. I've prepared 7 graphs. I'm going to talk about 7 different kinds of equations. The first we call linear equations. And the graph of a linear equation we call a line. Quadratic is its own function family, and the graphs of a quadratic we call a parabola. Cubic functions are their own family. As well as exponential, hyperbolic, or some people prefer reciprocal. Root functions and the magnitude function, which some people prefer to call absolute value. These are function families because all equations that belong to the family share some traits and features and graph essentially the same. The simplest linear equation that we can write is y is equal to x. So we call y is equal to x the parent form of the line. If I added 1 to x, it would create a different, unique equation. But y is equal to x plus 1 is also a line. It belongs to the family of linear equations. The simplest quadratic equation is y is equal to x squared. This is the parent form of a quadratic. I could transform this equation, y is equal to x squared, by adding and subtracting, multiplying, dividing. But as long as I have a squared term, then modifying it will still graph as a parabola. Cubic function's simplest equation is x cubed. So we call this the parent form of a cubic. Exponential's parent equation is y is equal to 2 to the x. Though some would choose the parent exponential base to be 10, 2 is a low, very manageable number. The parent form of a hyperbola, or a hyperbolic function, is y is equal to 1 divided by x. The simplest form of a root is y is equal to the square root of x. And the magnitude function can be expressed y is equal to the absolute value of x, which some would consider to not be a parent function because the magnitude function can be expressed as the sum of 2 other functions, but we're going to include it in our list here to begin the pre-calculus year. There are many other parent functions, but this is a good starting set. The next thing I'm going to do is sketch the graph of these parent functions, the parent equation of each. The equation y is equal to x graphs as a line with a slope of 1. And slope is a very important feature of linear equations, so I'll make a note of it here. The quadratic parent function graphs like this with its vertex at the origin opening up. A cubic function or a cubic curve looks like this, passes through the origin. Exponential function graphs going up. And part of the nature of exponential functions as they model either growth, which is the parent form because the base of the exponential here is 2, which is a number greater than 1, so the exponential curve is going to show growing or increasing numbers. But we can also model decay, or a curve that decreases if the base of the exponential is between 0 and 1. So growth and decay is an important feature of exponential functions. The graph of a hyperbolic function is called a hyperbola. It's fairly unique in that it has branches, and the hyperbola has asymptotes. The parent hyperbolic function has asymptotes that are the x and y axis. The root function starts at the origin and is represented only in the first quadrant. And the magnitude function is unique in that it has a corner. A sharp angular feature in the graph. The last thing I'm going to do is write down for each of these parent functions the domain and range. In the simplest possible way, we can say that a line, we can put all values of x into the linear function. The domain of a parent line is all real numbers. Most simply expressed, we could say all x. The range of the parent line is all real numbers. Simply, the easiest way to express is to say all y. Quadratic equation, we can put all x numbers into it, but it has a restricted range. We get only those out of the parent function or the parent quadratic that are equal to or greater than 0. Cubic function, we can put all x in and we get all y out. Exponential function, we can put all numbers x in, but we only get positive numbers out for y, so y has to be greater than 0. Hyperbolic function, we can put everything into it, but not x. The y-axis, or x is equal to 0, the y-axis is an asymptote. So we cannot put 0 in. It would cause a division by 0 error. Likewise, we cannot get 0 out of this function, so it's all y that's not equal to 0. The root function, we can put 0 and positive numbers in, but so x has to be positive or equal to 0, no negative numbers as input. And the y values that we get out are going to be positive or equal to 0. Magnitude function, we can put all numbers x in, but we will only get positive numbers and 0 out. We have 7 families of functions. Each family shares common traits, common graph. There are more than 7 types of equations. This is the set that we'll start the pre-calculus year with.